1. Explore.
The Arduino is an open-source electronic prototyping platform that can achieve multi-field tasks by coordinating required hardware components and coding aspects. This digital solution is to design and construct an Arduino electronic product and use the modular functionality of Arduino to fulfill a particular task.
This mind map contains three criteria: functional requirement, non-functional requirement, and constraints. Functional requirements provide what the program needs to do to successfully solve the given problem. The non-functional requirements are about what components will need to consider and what may influence the development of a digital solution. Constraints tell the possible limitation of the task. This Arduino digital solution requires the construction of Arduino electronics, as well as compilation of corresponding C++ code to operate an automatic farm. The functionality of the digital solution needs to contain an automatic feeding system to feed livestock, a temperature control system, and a light control system to maintain a good living environment. Evaluation criteria. This section is about the prediction of what components are required in completing the final digital solution. It will be used to reflect the success of this project as a conclusion. This is a prescribed criteria, which is about characteristic and fundamental requirements of the project for accomplishment of the task. This is a self-determined criteria, which is mainly focused on how to improve the project to make it more efficient and accurate. This is the constraints criteria, which summarize the social, personal, and economic restraint of the task. 2. Develop. This section is about the design of programming and electronics construction for the particular task, which includes the design of prototype Arduino device and the algorithm of the digital solution.
The task requires Arduino electronic devices to mainly achieve three functions. 1. Cooperating microservo with a paper door to control the open and close of the food passage. 2. Use temperature sensor to monitor the alternation of the temperature. When it reaches a certain degree, the system will sound the alarm and open the fan to decrease temperature. 3. Use ambient light sensor to detect the alternation of lightness. Open LED when environment becomes dim.
Below are the introductions for the components.
This is Arduino Uno. Arduino Uno in this task is a data process platform that is able to read input from each sensor and manage the output informational order after data processing. In this task, Arduino Uno is going to receive input from temperature sensor and light sensor. Then, by following the instruction of the code, Arduino will control the components of buzzer, motor, servo, and LED to react in different circumstances. Additionally, the Arduino is a power of entire farm that provides sensor electricity to generate. Besides, it is a bridge that can let users update or change the farm's program through computer. This is one of the input components, which is called LM35 temperature sensor. LM35 temperature sensor is an integrated circuit temperature device which output different proportional voltage. Each represents a certain degree of temperature. The temperature sensor in this automatic farm is used to operate the function of temperature maintaining. It will input a signal to the Arduino when temperature reaches a certain degree and send another signal when temperature changes back to normal. This is the second input component, ambient light sensor. Ambient light sensor can automatically adjust the brightness of the display depending on the intensity of the light. It is a light-dependent resistor, which will change its resistance when brightness changes. In this task, the role of the ambient light sensor is to detect the brightness inside the farm when the environment becomes dim. It will output the signal to Arduino Uno. These are two output components of the project, the buzzer and the motor. The buzzer is a tiny speaker that can connect to an Arduino. It can be used to sound a tune in different frequency. In this task, the buzzer will sound when the temperature is too high. 130 motor is a motor that can drive the fan. In this task, When temperature sensor sends a signal to the Arduino, stating that the temperature should be decreases, the Arduino will input a signal to the motor, then drive the fan to decrease temperature. This is the output component microservo. Microservo is an electronic device that can turn to any specific position within 180 degrees. In this task, the purpose of using microservo is to operate an automatic electronic lock. The lock controls open and close of the foot passage door. When the door opens, foot will drop by gravity. The door will open every 60 seconds. 5mm LED has two wires, which the longer one is the anode, and the other one is cathode. The current can only go in one direction, from anode to cathode. In this task, LED will turn on when the lightning sensor detects that the environment is too dark. When everything goes back to normal, LED will turn off. And then the resistor. The function of the resistor is to oppose the flow of the current through it. Resistors are able to limit the current and provide proper magnitude of the current, which ensures the safety of the entire circuit. 9V battery. Due to the Arduino can only provide 5V voltage, the current requires additional battery to drive high-power devices. The wires. Electronic wires are conductors that transmit electricity between devices and sources. Wires are usually made by copper, which have a high conductivity. And lastly, the breadboard. The breadboard is a solderless connection device, which can be used for temporary electronics constructions. These are the algorithms for the livestock feeding system, temperature control system, and brightness control system. 3. Generate. This section is about practical implementation of the automatic farm task. It also includes the construction of the Arduino electronic devices and the corresponding program operation. Construction of prototype electronic device. Section 1. Livestock feeding system. There are two components within the system, which is C1 and C2. Component 1 is a circuit which contains one microservo and three wires. The microservo connects to pin 9 on Arduino and also GND and 5V to form a complete circuit. Thus, the Arduino is able to control the servo through programming. Component 2 is designed as a pendant for the feeding system. It includes one LED, one resistor, and two wires. It connects to Arduino through pin 10 and GND. The aim of the resistor is to limit the current flow, which is able to protect the LED because LED's resistance is low. The construction detail is shown on the circuit diagram. This Arduino feeding system aims to feed livestock by open the food passage. When the servo turns to 90 degrees, the gate will open, and after a certain time, the gate will close, then the servo turns back to 0 degrees. While the gate is open, the LED should automatically turn on to remind surrounding people that the gate is open. The LED turns down when the gate is closed. Section 2 is temperature control system. It has 6 components, which is C1 to C6. Component 1 includes one 9V battery. Its anode connects to the GND, and its cathode connects to pin 8 through NMOS transistor, forms the circuit. The battery is able to provide higher voltage for the motor to make it operate properly. Component 2 include one motor, one diode. The motor connected to the 9V battery through a parallel circuit. The voltage within the parallel circuit is 9V, but the Arduino is only able to contain 5V. Thus, the diode is used in the circuit to limit the high voltage current within the parallel circuit, which the high voltage current that flows into the motor does not flow back to the Arduino. Component 3 uses an LED as a reminder to the users. When the environment temperature is above range, the LED will turn up as a sign of high temperature.
Component 4 is a transistor between the Arduino and the motor. The transistor is used when high current electronics is connected to the microcontroller. It is connected between the high current and low current loads. The transistor has three connections: the base, the collector, and emitter. The base is connected to the Arduino output pin. The connector is connected to the power source of the high voltage device. Then, emitter connected to the GND pin on the Arduino. Component 5 contains the temperature sensor, which is the input of the system. The temperature sensor has three rows of connection: the voltage, the GND, and output pin. The sensor will continually detect the environment temperature, then send the reading to the microcontroller to compare the data. Component 6 includes the buzzer and the resistor. The buzzer has two connections, which is the output pin and GND. The Arduino will activate the buzzer when the temperature is above the limitation. The system includes a temperature sensor as the input device, and a motor, a buzzer, and an LED as output devices. The temperature control system attempts to limit the temperature of the farm in a certain degree. The temperature device will continually compare the reading of the temperature sensor with the preset temperature limitation. When the environment temperature is beyond the limitation, the Arduino will activate the LED and the buzzer to remind user that the temperature within the farm is too high. Then the Arduino will open the fan at the same time to decrease temperature. If the temperature goes below the limitation, the output device will turn off. Refer the construction detail in circuit diagram. Section 3. Brightness Control System. The brightness control system has two components, C1 and C2. The system includes an ambient light sensor as input device and the LED as output device. The LED will turn on when the environment is too dark and turn off LED when the brightness changes back to the normal. Coded components. Section 1. Livestock Feeding System. The program can divide into 4 segments, which are able to achieve the function of automatically feed livestock. Segment 1 tells the program that the coding below needs to include the servo library, which means to activate a set of functions for the microservo. Segment 2 is a variable setting section. Segment 3 is a setup section for the entire program. It identifies the output. Segment 4 is a processing section, which runs in a loop. Section 2. Temperature Control System. The program can divide into 4 segments, which are able to control the function of control temperature. Segment 1 is a variable setting section, which is used to identify the pin. Segment 2 is a setup section. It identifies the output of the program and also states the serial connection with the computer. Segment 3 can transfer the raw data of the sensor to a temperature reading. Segment 4 tells the output devices how to do in different circumstances. Section 3. Brightness Control System. The program can divide into 4 segments. Segment 1 is a variable setting section, which is used to identify the pin number for each device. Segment 2 is a setup section for the entire program. It identifies the output and also states the serial connection within the computer. Segment 3 can make the reading of the light sensor displayed in the serial monitor. The interval of each reading is 1 second. Segment 4 is a process of function, which contains within the loop. Video demonstrating functionality. Video 1. Livestock Feeding System. Microservo spin, the foot drop, the LED turn on. Then the servo spin back and LED turn off. Video 2. Temperature Control System. In the video, the temperature is beyond the limitation, thus the LED, the buzzer, and the motor
are all activated. Video 3. The lightness control system. 4. Evaluate. This section involves testing, evaluation, and refinement. The purpose is to identify possible errors and find refinements throughout the project by several tests, then decide whether the project completed the task and fulfilled the user's requirements according to collected data and evaluation criteria. Below are the testing and refinement. There are 3 systems need to be tested. 1. Livestock feeding system. 2. Temperature control system. And 3. Brightness control system. This is a test for livestock feeding system. The main issue found during testing is that the expected outcome is microservo will turn 90 degrees, then turn back to 0 degrees afterwards. But the actual outcome is the angle that servo turns is less than 90 degrees. So the refinement is change the turning angle to 95 degrees because the servo device has an error during the operation. The actual angle is less than the expected value. Test below is for the temperature control system. The refinement for the buzzer is to adjust its frequency. The test found out that the Arduino does not need a 9V battery to make a fan operate. Thus, the final solution is to remove the battery and make this system more concise. Tests below are for the brightness control system. The expected result is LED will turn on or off depending on the amount of light the ambient light sensor receives. But the actual result is the LED turn on or off randomly. So we assume that the ambient light sensor is connected in the opposite direction, thus the rating of the sensor is incorrect. After reverse the ambient light sensor, the system works properly. This part includes evaluation and recommendation of the entire project. Analyze and coming up with a reliable and comprehensive evaluation which shows how successful this entire project is. The section then identify opportunities for improvement in the future. The project achieved all of the plan of the prescribed criteria, which states that the project accomplished its fundamental requirement. The evaluations for the self-determined criteria are, initially, the project uses more components than it needs, such as a battery and transistor. Additionally, the temperature control system cannot function well if the environment temperature is too high, because Arduino cannot provide a strong power to the fan. In general, the project achieves some of the self-determined criteria, means the project is relatively efficient and accurate, but it still has place to improve. Then lastly, the project achieved most of the constraints, means the project can relatively fit into the social, personal, and economic restraint. In conclusion, this project is relatively successful, but it still needs progress, such as makes the program and constructions more concise. As the evaluation shows, the project can completely accomplish the fundamental requirements of the task. It is able to achieve most of the progressive criteria, as well as the most social, personal, and economic requirements. The tests will indicate that the design and generation of the electronic devices are successful.